What's up, guys? It's Carlson, and I'm here to hang out and do some Math 180 stuff with you. If I haven't screwed this up, this should be Lesson 4. Lesson 4 in Block 6. We're going to do this, and we're going to enjoy the sounds of my roommate in the other room playing video games and stuff. I don't know if you can hear that dude rumbling and just firing rounds of ammunition all over the place. I'm sure that he's causing a great deal of death and havoc. So, anyway, we're going to go ahead and start here. It says, tell me all that you can about this equation y equals 4x plus 5. Well, I'll give you a chance to think. Okay, chance over. Let's talk about what's happening here. Here's some stuff that I came up with. We've got a slope of 4, because I can see it right there. Our initial value is 5, so even if there are no x's, we still have this 5 that we started with. For every 1 that x increases, y increases by 4. That's kind of the meaning of this slope, or this rate of change right here. And then to go back to yesterday, our equation is always going to be 5 greater than y equals 4x. If I had this y equals 4x equation right next to it, and let's say I plugged in 3, 4 times 3 would make 12. Well, 4 times 3 here would make 12, plus 5 is 17. It's always going to be 5 greater on the plus 5 side. So this keeps a constant lead for this equation over here. Look, if you came up with, some of those, great. If you came up with none of those, that's also great. You do you, all right? Let's go ahead and move on to today's topic. Here's our try problem. Akeem, an economist, advises his clients to invest in a stock selling for $10 a share. The share price is growing by 75 cents per week. We're going to write an equation to represent the share price for any number of weeks. So they've given us two values here. Two values being $10 a share, and also giving us this 75 cents per week that we've got here. Now, this is a dead giveaway. When I see per week written right here, that's telling me that this is happening over and over and over again. It's increasing at a constant rate. So when I look down here and I see rate, I know, hey, that's the spot for my per week number, 0.75. My initial value then is the $10 we started with. This thing begins at $10 before it does any increasing whatsoever. And now we go to write our equation just by plugging these guys in. This per week part tells me that this is what goes with our variable, or with W, so I'm going to put 0.75 in front of it. And then my $10 plus 10 just goes out there all alone. Sad story. Okay, so if that seems pretty simple, then you're going to have an easy time today. We just need to identify which one's our starting value, and then do we have a number that is increasing the same amount over and over and over again. All right, so let's check this out. Kayla, a restaurant owner, donates $300 to charity on her opening day. Each week she donates $30 more. We want to write an equation to represent Kayla's total donations for any number of weeks. Okay, we're going to start off by identifying what x and y represent. I'll put an x in here and a y in here. So what's changing in this problem? Well, clearly we're talking about money here. So money is going to be one of them. There's our $300. We've got $30 down here. What's causing the dollars to change, though, is the time passing. So here's our weeks here. Each week. Anytime you see each, you see per, anything along those lines, that's telling you this is a variable, and not only that, this is the variable that is represented by x. So x represents the number of weeks. Apologize for my handwriting. I'm trying to do this on my touchscreen laptop, and I'm not very good at it. So if x represents our number of weeks, that means that the dollars must be represented by y, the dollars of her donation. Her initial value is going to be this $300 she put up at the outset, so we'll start there. And then the rate is the repeated value. That's $30 more each week, remember. So our rate is 30. Because this is my rate and it's happening over and over and over again, it's going to get an x or something with it when we go to write our equation here. So let's make it y equals, it's like our mx plus b. There's your rate, 30x plus our initial value of 300, and we're finished. Seem good? Cool. Things to watch out for. Make sure your rate goes with the x and your initial value goes naked. Secondly, you see this each or this per word, you know that that is representing x. Let's try one more. Erica's a web editor, and she's paid $1,000 to create content on a website. She makes an extra 50 cents every time someone clicks an ad. Write an equation to model the scenario. All right, I know that we're going to talk X and Y here. Do you see the number that tells us where the rate is at? Do you see something like each, like per? You do. You see a clue. 50 cents every time. That tells me that this is our like each or our per, which means that every time someone clicks on an ad, 50 cents every time someone, for each click. So we'll call this, X represents the number of clicks. That each or every word, 50 cents every click. Cool. Well, now we're talking about money again, so Y is just going to represent the dollars. Dollars are the amount that she's paid. Cool. Once we've got that, we've got to answer for our initial value. How much do we start off with? Well, Erica gets paid $1,000. Regardless, if nobody clicks on her stuff ever, she's still made out with $1,000. It seems like a bad way to spend money if nobody's going to click on your ad. But we're assuming she's good at her job and lots of people are going to click on her ad. So our rate is going to be that every number, which is 0.50, 50 cents. So it is time for the equation. Here it comes, y equals mx plus b. Y equals, put your rate with x, plus our initial value of 1,000. Voila. The math. It's done. How nice. This slide says practice on it. I don't really feel like practicing. I feel like you guys should do some practicing. You should go ahead and try this out for yourself. Make sure that you feel comfortable. And you should pause me right now because I'm going to reveal the answers in about 4 or 5 seconds. Okay. This is what I think the answers should be based on what I've seen. In number 3, we've got M and P standing for number of months and internet plan, respectively. We've got an initial of 100 and a rate of 50, so that makes our equation P equals 50M plus 100. Do note that if you guys chose to write Y equals 50X plus 100, I'm not mad about that. I think that's okay. But we do want to pay attention when they give us directions and specific variables to use, to think about slipping those in instead. Number 4 says number of bottles sold is B, and the total payment is T. Initially, we have $620, and our rate is 15 cents per bottle. So there's our rate. We're going to put our variable with it, so 0.15B, 0.15 per bottle, plus the 620 we started with, and that gives us P over here. P equals 0.15B plus 620. That's about it for today. There's an exit ticker right here about Sasha. I would like you guys to try this, and as soon as you take care of it, feel free to pack your books up and go find yourself a Chromebook, which I'm hoping Mr. Morgan brought over. If Mr. Morgan did not bring those over and you are the first person to notice, would you please let the sub know and then go snake those out of his room so that everybody can use them today? All right? Thank you guys so much for taking care of business today. Be nice to the sub. You always are. You're good kids. So I will talk to you on Wednesday. Have a good one.